This is example 1 in section 1-3. We have this function, calling it f of x, because it doesn't really have an equation that would fit it. We could make a piecewise function that fits it, but we don't need to for what we're doing. We're going to graph the function y equals f of x plus 2. So first of all, since we know that f of x means the y value, f of x plus 2 means we're adding 2 to the y value. Alright, let's kind of get that out of the way. So the point at 0, 1 becomes the point 0, 3. And that's because we add 2 to the y value. The y value is 1. 1 plus 2 is 3. The point at 2, 3 becomes 2, 5. We add 2 to the y value, which is 3, and we get the y value 5. The point at 4, 3 becomes the point 4, 5, because the y value is 3, and we add 2, so we get 5. And the point at 5, 5 becomes 5, 7. We add 2 to just the y value, we get 5, 7. So to graph this, we're going to take these points and graph them. So we have a point at 0, 3. We have a point at 2, 5. We have a point at 4, 5. And we have a point at 5, 7. Hopefully you can see that we have exactly the same graph shape. Just the entire thing has been moved up 2 because of adding 2 to the y value. So just writing that down. Graph moves up 2. Let's look at example 2. Now we have vertical reflections. We're going to graph a vertical reflection by changing the sign of the y values. So instead of the y value 0, 1, we will have the value 0, negative 1. Instead of 2, 3, we will have 2, negative 3. Instead of 4, 3, we will have 4, negative 3. And instead of 5, 5, we will have 5, negative 5. That just comes from multiplying our function by a negative. So if this was an actual equation, instead of just our f of x notation, it would be a negative in front of what's ever happening in that equation to take it from its original shape to this new shape. So let's see what happens. We have our point at 0, negative 1, our point at 2, negative 3, our point at 4, negative 3, and our point at 5, negative 5. Let's connect those together. Again, we get the same basic shape. But this time it's been reflected upside down over the x-axis. So multiplying your entire function, usually just a negative in the front of what's happening, multiplying it by a negative changes all of the signs of all of our y values. So in this case we had positive y values, so they all changed to negative. If they were negative, they would change to positive. It just has the effect of taking that graph and flipping it over the x-axis for a vertical reflection. Last vertical one is vertical scalings. So again, we take our function f of x, which is this picture, and we're going to multiply by 2. So f of x is times 2. That means our y values are going to multiply by 2. So we take our point 0, 1, and we multiply our y value by 2. We take our point at 2, 3, and we multiply just our y value by 2, and we take our point at 4, 3, and we multiply just our y value by 2, and then we take our point at 5, 5, and we multiply just our y value by 2. So here's our new points. So we have a point at 0, 2, we have a point at 2, 6, we have a point at 4, 6, and we have a point at 5, 10. Connect the dots. Hopefully you can see the result. We have the same basic shape, but it's sort of skinnier. If you look at the overall picture, it's a skinnier version of the function as it was given. It's not really actually skinnier, it just has that appearance. What it actually is that it's been stretched so that it's twice the height it was. It's been stretched by what we call a factor of 2. Stretched by a factor of 2. If we use a fraction instead, we would be compressing it, and it will be shorter. We would call that a compression. So if the number in front of f of x was a fraction, then instead of multiplying by a number that makes the y values bigger, a fraction would multiply the y values and make them smaller. And so we would call that a result compression. So vertical compression. If our scale factor that we're multiplying by is less than 1, and by less than 1 I don't mean negative, I mean the absolute value of it is less than 1, so it's a fraction, so maybe it'd be better to say it's between 0